it's unit circle day 3. So we're going to take what we know about the unit circle as well as coterminal angles to put them together. And I'm also going to introduce you to quadrantals. So now let's take everything that we know about unit circles and coterminal angles to answer some questions. So the 3 problems that I want us to consider is sine negative 210, tan 5 pi over 3, and secant negative 3 pi over 4. So remember, negative just tells us a direction. The issue is that we don't have negative numbers in the unit circle. So we've got to consider and use what we know about coterminal angles to make that negative a positive. So just as a recap, coterminal angles are angles that have the same initial ray and terminal ray, however, they go in different directions. So to make this negative 210 positive, we're going to add 360 to it. So we're going to get 150. So the problem is going to transform to sine 150, and that's back to what we did on Monday. Use making sure that you're going back to that unit circle, go to the y coordinate, and you should get that the answer is 1/2. Now let's take a look at sine 5 pi, or tangent 5 pi over 3, okay? So this one is a review from yesterday. 5 pi over 3 is going to be inside of my unit circle. So let's take what we know about tangent equaling sine over cosine. So we're going to create that crazy looking fraction within a fraction deal. So I'll have negative root 3 over 2 divided by 1/2. Keep, change, flip. 2's cancel, so I get negative root 3. Done. Now let's take a look at secant negative 3 pi over 4. Same idea, we don't have the negative, so we're going to use a coterminal angle. We are going to add 2 pi, but I'm going to write it as 8 pi over 4. So I get 5 pi over 4. So now my problem transforms to 5 pi over 4. Now with secant, what I need to do is take the reciprocal of cosine. All right, so if cosine is going to be root 2 over negative 2, so all I did was flip it. The problem is that you're not allowed to have a square root on the bottom. So you've got to rationalize your denominator to get negative root 2. Okay, so now let's talk about quadrantals. Quadrantals are angles whose terminal side is going to lie on an x or y axis. That's it. So we're going to be living in the 90, 180, 270 land. So let's take a look at negative 270, tangent 3 pi, and secant 11 pi over 2. So again, we're not allowed to have that negative there, so we're going to have to use what we know about coterminals. So I'm going to do negative 270 plus 360. That's going to give me 90. So I want sine of 90. Y coordinate, so you get that your answer is 1. Okay? Tangent 3 pi. Again, we're going to have to use what we know about coterminal. So we're going to take our 3 pi and we're going to subtract 2 pi. So I get pi. So tangent pi is going to be a fraction within a fraction. So I have sine over cosine. So that gives me 0 over negative 1, which is just 0. Secant, this one's going to be fun, okay? So we're going to have to use what we know about coterminals here, okay? So first thing I'm going to do is take out 4 pi over 2, because that's 1, which gives me 7 pi over 2. The problem is it's still too big. It's bigger than 2 pi, so I can't use it as a reference. So I'm going to have to subtract 2 pi again. So when I subtract it again, I get 3 pi over 2. So you could subtract more than one time. So when I have secant 3 pi over 2, I want the reciprocal of cosine, sorry. So when I do the reciprocal of a cosine, that is going to give me 1 over 0, which is not allowed. 0 is never allowed in the denominator of a fraction, ever. Okay, so when that happens, your answer is undefined. My little song that I like to sing is 0 on the top is okay. 0 on the bottom, no way. Your turn.